Good morning, students. Today we will discuss in the operating system lecture series. Today we will discuss the threads. In the threads, we will discuss the program threads and system threads. Okay. So in this program threads, we will discuss Trojan horse, trapdoor, stack and buffer overflow. And in the system threads, we will discuss worms, viruses, and denial of services. Okay. So first of all, we will start from Trojan horse. A Trojan horse is a program that secretly performs some maliciousness in addition to its visible action. So whatever the visible action that is performed, but in addition to that, it is also performed some malicious acts. Some Trojan horses are deliberately written as such, and others are the result of legitimate programs that have become infected with viruses. One dangerous opening for Trojan horses is long search paths, and in particular paths which include the current directory. It is represented by a dot sign as part of the path. If a dangerous program having the same name as a legitimate program or a common misspelling such as SL instead of LS is placed anywhere on the path, then an unsuspecting user may be waiting for a program by mistake. So another classic Trojan horse is a login emulator, which records a user's account name and passwords, issues a password incorrect message, and then logs off the system. The user then tries again with a proper login prompt, logs in successfully, and doesn't realize that their information has been stolen. So this, one should be very, taken care of these things. It's very, it can be very dangerous also. So there are two solutions to Trojan horses are to have the system print uses statistics on logouts. Mean to just take the uses statistics on logouts and to require the typing of non-trappable key sequences such as Control Alt Delete in order to log in. So these two things one can taken care for just to avoid Trojan horses. Spyware is a version of a Trojan horse that is often included in free software downloaded off the internet. Whenever sometimes you are finding that is a particular software is a paid and it is offering somewhere that it is you can download it free. So spyware program generates pop-up browser windows and may also accumulate information about the user and deliver it to some central site. This is an example of covered channels in which super PTS communications occur. Another common task of spyware is to send out spam email messages which then purportedly come from the infected user. Now the another thing is the trapdoor. A trapdoor is when a designer or a programmer or hacker deliberately inserts a security hole that they can use later to access the system. Because of the possibility of trapdoors, once a system has been in an untrustworthy state, that system can never be trusted again. Even the backup tapes may contain a copy of some cleverly hidden backdoor. A clever trapdoor could be inserted into a compiler so that any programs compiled with that compiler would contain a security hole. This is especially dangerous because inspection of the code being compiled would not reveal any problems. Another thing is the logic bomb. A logic bomb is a code that is not designed to cause havoc all the time, but only when a certain set of circumstances occur, or you can say a particular time when these particular circumstances occur, such as when a particular date, let's say in a particular date, every 20th of month or some particular date or time is reached or some other noticeable event. So a classic example is the dead man switch, which is designed to check whether a certain person, for example, the author, is logging in every day, and if they don't log in for a long time, presumably because they have been fired. So then the logic bomb goes off and either opens up security holes or causes other problems. Another is the stack and buffer overflow. So this is a classic method of attack which exploits bugs in system code that allows buffers to overflow. Now consider a scenario, you just see the code here as include, let's say stdio.h is defined. We have defined here the buffer size equals to 256. Now we are just making a main function main integer argument and then a character pointer argument, array of character pointers. In this we are having character buffer, buffer size, which we have defined in the upper part. There is a buffer size equal to 256. If argument is, if RC is less than 2, then return -1. Else copy the string, that is buffer argv1, return 0. So this is the classic method of attack which exploit bugs in system code that allows buffers to overflow. So this strcpy command will overflow the buffer, overwriting adjacent areas of memory. The problem could be avoided using strncpy with a limit of 255 characters copied plus room for the null byte. Then it can be, corrected. Now the worm. A worm is a process that uses the fork and spawn processes to make copies of itself in order to break havoc on a system. The worm is, creating its own processes. So as you know, in the Unix system, we are using the fork process to create the new process. So worm is also creating its own processes. Worms consume system resources, often blocking out other legitimate processes. Worms that propagate over networks can be specifically problematic as they can tie up vast amounts of network resources and bring down large-scale systems. One of the most well-known worms was launched by Robert Morris, a graduate student at Cornell in November 1988, targeting Sun and VEX computers running BSD Unix version 4. The worm scanned the internet in a matter of new route and consumed enough resources to bring down many systems. Now there is another system threat that is called the virus. A virus is a fragment of code embedded in an otherwise legitimate program designed to replicate itself by infecting other programs and eventually breaking havoc. Viruses are more likely to infect PCs, or you can say the Windows system, than Unix or other multi-user system, because programs in the later systems have limited authority to modify other programs or to access critical system structures such as the boot block. Viruses are delivered to systems in a virus dropper, usually some form of a Trojan horse. Okay, viruses takes of many forms. The Typical operation of a boot sector virus is virus copies boot sector to unused location X. Then virus replaces original boot back with itself. At system boot, virus decreases physical memory, hides in memory above new limit. Then the virus attached to disk read-write interrupts, monitors all disk activity. Whenever new removable read-write disk is installed, it infects that as well. It blocks any attempts of other programs to write the thing. It has a logic bomb to break havoc in a certain date. Forms of viruses, there are different forms of viruses like file, boot, file. A file virus attaches itself to an executable file, causing it to run the virus code first and then jumps to the start of the original program. These viruses are termed parasitic because they do not leave any new files on the system and the original program is still fully functional. Boot, a boot virus occupies the boot sector and runs before the OS is loaded. These are also known as memory viruses because in operation they resides in memory. Okay. Macro, these viruses exist as a macro or you can say a script that are run automatically by certain macro capable programs such as MS Word or Excel. These viruses can exist in word processing documents or spreadsheet files. Source code, viruses look for source code and infect it in order to spread. Polymorphic viruses change every time they spread, not their underlying functionality, but just their signature, by which virus checkers recognize them. Encrypted viruses travel in encrypted form to escape detection. In practice, they are self, you know, describing, which then allows them to infect other files. Forms and S-stealth viruses try to avoid detection by modifying parts of the system that could be used to detect it. For example, the read system call could be modified so that if an infected file is read, the infected part gets skipped and the reader would see the original unadulterated file. Tunneling viruses attempts to avoid detection by inserting themselves into the interrupt handler chain or into device drivers. Multi multipartite viruses attack multiple parts of the system such as files, boot sector and memory. Now this is the denial of service. Denial of service attacks do not attempt to actually access or damage systems, but merely to clog them up so badly that they cannot be used for any useful work. Tight loops that repeatedly request system services are an obvious form of this attack. Denial of service attacks can also involve social engineering, such as the internet chain letters that say send this letter or send this message immediately to 10 of your friends and you will listen one uh, good message or the good things and then go to a certain URL. Okay, so when you are accessing that particular URL, you will you will think and you will go to the one non-reliable source. Sometimes denial of service is also that your system is flooded with so messages that whenever you try to access the thing, that is denied due to there are a lot of messages and the system gets slow. So that is also the case. So these are different facts One is the program threats and the system threats. In this, we have also discussed denial of service, very important, different forms of viruses, and this the typical operation of a boot sector virus, different virus, worms, Trojan horse, forms of viruses we have discussed, denial of service. This is some of the references with token. Thank you. And then the next topic is the last topic we will discuss encryption. So here I will stop. Okay. So thank you.